Welcome back. Today's lesson is going to be on stoichiometry. And stoichiometry is where we take a quantity of some reactant or product and we compare it to a different reactant or product. When you start stoichiometry problems, you always need to start with a balanced chemical reaction.
So if you look at this reaction, you have two reactants, one product. This is a synthesis reaction, and if you look at it, you'll see that it is balanced. Now, what we're going to do when we look at stoichiometry is going to take a certain quantity or certain amount of one of these reactants or one of the products and compare it, as Mr. Rollick said, to the quantity of a different reactant or product. So for example, if I said that we had 6.0 moles. Now, what is 6.0 moles? These coefficients that we've been using to balance, these represent the moles. So we're going to use something called a mole ratio. So for example, in this reaction, for every 3 moles of hydrogen, you can make 2 moles of NH3, of ammonia. Right? This is a mole ratio. This is a 3-to-2 ratio, and we call that the mole ratio. And we're going to use that when we compare reactants and products. So let's take a look and see if I had, for example, 6.0 moles of hydrogen. That's what I'm starting with. That's one of my reactants. I'm going to put that over 1. Now I'm assuming that I have as much nitrogen as I need for this reaction to happen. And the question is, how much of this ammonia can I get if I put in this much of the reactant? So what I'm going to do, same conversions we've done before. I'm going to start with my given, right, which is the problem will give you. I'm going to take the old unit and put it down here, moles of hydrogen. And I'm trying to find out how many moles of ammonia I can make. So my new unit is moles of ammonia. Now, what numbers go here? This is where we look at the mole ratio. For every 3 moles of hydrogen, I can react it to form 2 moles of ammonia. So the 3 moles of hydrogen goes here. The 2 moles of ammonia go here. This is the mole ratio that I'm using in this problem to figure out the relationship between this reactant and that product. Now we do the math the same way we always did. We multiply across the top. So I'm going to get 12 on top, 12.0, 3 on the bottom, right? Multiplying across the top, multiplying across the bottom, and I end up with 4.0 moles of ammonia. Okay? I got rid of my moles of hydrogen, now I have moles of ammonia. So that is what we call a mole-to-mole conversion. We had a quantity of a reactant, we're finding the quantity in moles of the product.
In stoichiometry, we use moles because that is the only way we can compare one chemical to another. It's super useful in order for us to do the math behind stoichiometry. But in the lab, we can't go back and actually measure moles of something. I can't go back and find 4.0 moles of NH3. So instead, we take it one step further and we're going to convert from our moles into grams, because grams is something I can go back on the balance and actually find. So we set up one more problem. We take our old unit that hasn't canceled out yet, which is our moles of NH3. Okay, and this time I want grams. So we're going to change it from moles and we're going to turn it into grams, and it's still going to be NH3. Okay? Anywhere you use moles that's not the mole ratio, you always put 1. And your grams, you have to do a calculation for the molar mass. In that compound, we know we have nitrogen and hydrogen. We have 1 nitrogen, 3 hydrogens. We multiply them by the mass on the periodic table. Hydrogen is 1.01. Nitrogen is 14.01. And we multiply across. 14.01, 3.03. We add them together to get a total of 17.04. This is your grams for ammonium, the ammonia, where you're going to put here in your problem, 17.04. Okay. So again, this is your 17.04. This is your molar mass, and we found that on the periodic table. Okay. So now we multiply all of our numbers across the top, and when we do that, we get 204.48. We multiply all of our numbers on the bottom. We get 3 times 1 times 1, which is 3. We can go back and look at our units. The moles of NH3 cancel, so we're left with grams of NH3 for our final answer. We take our top number divided by the bottom to get a final answer of 68 grams of NH3. We again make sure that we have the right significant digits for our answer. Because we started with 6.0, that's 2 significant digits. Our final answer has to have 2 significant digits.
So to summarize, we just learned about stoichiometry. Stoichiometry, we are looking at the quantities of a reactant or product and comparing it to quantities of a different reactant or product. Now we can do this moles to moles, right, using the mole ratio, or we can go a step further and turn those moles into grams or liters or particles like we've done in class.